Okay. Okay. Good. Yes, hi, Philip. So hi, Danish. Yeah. Okay. So we have this repository, which is called Basics Graphics Music, and basically, in order to get this repository, you need to just clone it, and then you need to go to a branch called New Graphics, because we are now modifying everything. And because we are modifying everything, you need to get branches. This branch will become main after about a month, so on September 15th. So now, once you clone it, so do you usually work with, so you presumably work with Linux rather than Windows, right? Or do you work with Windows? So which one?
I have a Mac.
You mostly Mac. Yeah, unfortunately, most synthesis tools do not work on Mac. So so does Yosis work on Mac?
Yeah.
Okay. In this case, you should be able to use it on Mac. So our script's compatible with Mac. In fact, if you run only simulation, it works on Mac. So they should work on Mac. And if it works on Mac, so you can actually test it on Mac. Yeah. So if it works on Mac, this is great, because all our scripts are Bash scripts, and they work with Mac Brew just fine. Yeah. So what you do is that you clone a repository. Then, so are you using like a VI, or using like Microsoft Code, like VS Code, or what kind of?
VI and VS Code.
Yeah, VS Code. Okay. So usually what we recommend use during the seminar to use VS Code. And but I personally use different things. So I will show you with the like personally I use Midnight Commander. Hey, yeah. So yeah, so I personally use Midnight Commander, like, and I will show it here. But usually what we do is that we go to VS Code, like during seminars, and we open this repository, and then we create terminal, and then in this terminal we run scripts.
Okay.
And basically you need to run only one script, which is like push button script, like do everything. So, but I will show this in a Midnight Commander, which is tool like I'm using. So basically in our directory, there are like bin, boards, docs, labs, misc, and so on. And for users of the example, so first I will show how it looks from the point of view of user, but I will also look from the point of view of developer, because I want you to port it on your latest boards. Yeah, so for the user, you go to labs, and this has the example for the users.
Okay.
And there are some like basics, and then graphics, then musics, which work with the microphone. So there is a microarchitecture, which is with the 5 host pipelines, with the data processing pipelines. And they are like already on like interview level questions, because during interview we ask students to like build some like pipelines with the credit-based flow control and the 5 hosts and so on. And then we have this like very simple CPU. Yeah, which is a subset of this. So this is like 300 lines CPU. But interestingly enough, that its CPU is large enough to make interesting interview questions. You know, but this is like, so you have like LU, which has like 5 instructions, and you have decode, which decodes like 3 types of instructions. And this has like control block, which generates control signals for the LU. Yeah. Just exactly. So and then it has a register file with the. Then it has register file, which just has ports for reading and writing registers, and it has a CPU, which just instantiates those modules. Yeah, so it has a CPU, it just instantiates modules, and it has a simulation, so you can simulate it. So this has like Zen scripts. Those scripts here are actually redirect bash scripts. So actual scripts are located in different place. Actual scripts are located in directory scripts, but user never actually look to those scripts. And those are scripts which work with all the different tool chains, including USS for both ASIC and FPGA. So it uses with Xilinx, with Altera, with Govin, with eFinix, and so on. So script cleans everything, simulate. It actually simulates using Icarus Verilog, and then it shows yes the GTK wave, and inside it also uses RAR's simulator to compile your like assembly code into hex file. So you actually load hex file. So this hex file here, so you have like hex file, and this is loaded in a program memory. So this is our like initial program which computes a Fibonacci number, and then you load it into a program memory, and program this is instruction ROM. So it just uses read mem h, which is sufficiently processed by simulator or by synthesis, and then the only script you run is a script called synthesize and configure. So now let's actually run something a little bit more interesting. So let's run with a graphical screen. So you can no, let's run first basic script. So what you do is that you go to like basics. Let's run like let's say like shift register. So basically what you do is that you run script, choose another FPGA board, and you have like list of boards to choose. And this particular configuration we want to use is called 10 Nano 9K LCD No TM 1638. It means that we do not connect this little thing to it, and we just use the buttons and the LEDs on the board. So we choose number 52, and then we do synthesize, and this just synthesizes according to what we have. A second, did I connect it? Yeah. So here you're using one button as a reset. So this button is a reset, and this is the only one button which you use to just push data to this shift register. Okay. Now next thing we will do is that we will run something graphical. So we connect a graphical screen to it. So we connect graphical screen to it, and now the good thing about graphical screen is that you can do again. So you can actually use it from the very first exercise, because yeah. So now the another member put this color stripe. So let me show you. This is even more simple. So basically we have a bunch of wrappers, which is board specific wrapper. And this board specific wrapper instantiates parameterizable module, which is common for all boards. And we have like a parameter for this module. So what is the clock frequency, how many keys, how many switches, how many LEDs, what is the like screen size, the number of colors per channel. And if you look to go to board directory, what user usually don't see, but if you go to like, let's say like 10 nano K, if you go to this node TM this actually just directs to another file. And when you go down to this file, you can see that this has connection with the pin specified in CST file, which defines mapping. And then like it instantiates this laptop propagating proper number of everything. So on this board, and this configuration has only 2 keys, and 1 key is used as a reset, has 6 LEDs, has no switches, no 7-segment display. And we put it screen, which is 480 by 272. So here we are putting some module which has like LCD graphic interface, and basically this module it generates signals for the screen, which is like sync, and it generates coordinates x and y, and it gives x and y to your module, to user module, and user module produces colors for this x and y. So now all you need to do to generate interesting picture is that you need to use this x and y and tell what color it is. So the simplest is that to generate stripes. So you are checking that if x is less than 128, then red shades of red, then and so on. So if you synthesize this thing, so what we are going to get is okay, didn't synthesize. Whoop. No, something is broken. One sec. Oh, sorry. I didn't properly put inside. A second. I didn't connect it properly. So you need to put it inside and then lock. Okay. Also did some changes, so I hope you did. Okay, so now you can do script configure it. Yeah, so now you can see that it created shades of colors. And also, so suppose you want to draw like circles. So what do you do? How do you draw a circle? So you have x and y.
Yeah.
So you have x and y. So how do you draw a circle?
Just the equation of function.
Yeah. So you do equation for circle. That's true. So you basically use x and y. Oh, why this is changed? Did it change it? What? A second. Somebody changed something. Okay, so now I think as I was changing on this particular computer. That's why it's changed. Okay, git already up to date. Yeah, I changed here something, so let's change it back. Okay. Yeah, so basically in order to draw ellipse, you just get that if x square plus you draw ellipse and you can draw a parabola. So then if you synthesize this thing, yeah, so you see, synthesis speed is quite fast here. So yeah, you see, so it goes such thing. Now, how to make everything moving? So basically, to make things moving, to add sequential logic, what you do is So what you do is you just create a module which generates strobes 10 times a second, and then like you 10 times a second you like increment some counter, and then you add it to the coordinate. So basically, if you see, so basically this is what I'm doing here. So I'm getting some like dx 10 times a second. I do plus, and then I put colors based on this additional coordinate. And then we synthesize this thing. Yeah, but so now let me show you. Yeah, and you can get some like such like movements. So you can, yeah, and also there is some little game here, and so on. So basically, for lattice support, if you want to do everything with the lattice, so let's get something with the lattice. Let's get, for example, this one. I'm not sure what board is this. Or let's get orange grab board. So a person who did the implementation, he simply put his own makefile. So usually I don't use makefile. I usually just use script, but he just preferred to do it as a makefile. So he was using Yossi's tools here. So Yossi's next PNR tool, and so he put this mapping of pins to and then he put board specific top SV. And in this board specific top SV, he put parameters, ports, and then he connected this thing, and then he instantiated laptop, and that's it. And then he like instantiated microphone and sound out. Yeah, this is also what is. Yeah, so this is like small module, like 200 something, and maybe you can do it right away. So if you want to try, because it's kind of very plain, Verilog, which you like already know. So yeah, so this is one thing what we are using those examples for. And then there is another thing called system Verilog homework. And system Verilog homework is another repository which you also can get from like my account in GitHub. And basically, it's also like bunch of like simple tests which start from very basic. So you have like multiplexer from 2, and you need to create multiplexer from 4. But then it goes like more and more complicated. Finally, it goes to like FIFOs and CPU with all those like interview level questions. Like you get CPU with combination and multiplier, make it with a latency. Or you get memory with a latency, or you get 3 CPUs sharing common memory and stuff. So basically, in order to run this, so to run it on like Linux or like on Mac, you just run this script, this like bash script, and it just runs all examples here. So now wait a second, why did it say pass? Oh, yeah, we recently changed this repository. So now, yeah, so now system Verilog is okay. Yeah. Okay. So you see now like everything fails because no questions are answered. So basically your goal is to make everything pass. Yeah. So yeah. so it's a very first step what you can do like even now, so you can get your laptop and sit down and try to see how far you can go here.
In the Verilog homework.
Yeah, like it's a very low homework. Then you can also assemble with the Stand Nano. You can assemble like everything together and run with the Tank Nano. That can give you one set as a reference. Then you can do the same thing for your lattice boards. Yeah. So now, in order to so basically to assemble setup for Tank Nano. If you go to verilogmeetup.com, you can see that we have article called self-education and educating others. This article has all the links what you need to have to the repositories and so on, and like to the literature and to the projects. So basically, what you yeah, but the problem is that for 10 nanos they don't have they don't have like commercial tool chain for Macintosh, so you need to use like Linux computer. But I have some extra Linux computer, so you can use another laptop right now. And for so now you in order to figure out how to assemble together all the setup. So what you need to do is that you need to get a website cpid 10 nano 9K, and this has a picture of how pins are located. So a picture with those pins. Okay. And then what you do is that you go to a board 10 nano 9K, and then you look inside CST file, which has a comment showing where things are connected. So this one connects to microphone. So you need to connect display and you need to connect this TM1638 module, because this is what we need with like CPU, with FIFO and so on. And then like you can assemble. And while you're trying this, I will talk with other people, and we will start to do some like board testing, what is supposed to be the main topic of today. So one thing what I'm doing now, I'm like trying to make some like a meetup in Los Angeles next Saturday. And so like I will fly there because my son got accepted in UCLA, so I need to go to UCLA with him. And I decided that if I'm there, I can do something. Plus, I'm going also to visit Harvey Mudd college with a professor David Harris, who is author of a textbook on like RISC-V. So do you know his textbook is Harris and Harris? If you don't know, I mean, like this material he has the same as in like a Patterson Hennessy book, but yeah, but his book is essentially 5 book in one, because he has both. Yeah. So this is the book. Yeah. So this has chapter on computer architecture, chapter on digital logic, chapter on Verilog and VHDL, and chapter of how to use a chip. So like I'm going to meet with Professor Harris, and maybe also get some like other people. So yeah, so you can just like get this like homework and just start on homework and just see how you can go. And so let me chat with other people. So one thing what I want to do today is that I want to do a review of many FPGA boards because I was doing editing of like work of other people. Yeah, so but the person who was doing D0CV didn't come today. Maybe he will come later. So I want to make this review with him. But let me start with the testing D0. But before I start doing this, yeah. So let's ask you. So what did you do during
So
last
I
week?
tried it, and instructions were too hard to follow, so it failed. If you can give me a Linux laptop like last time,
Yeah,
I
sure.
will look at it.
But what exactly did you try to do?
So I tried to use the Windows toolchain,
Windows toolchain, okay.
and maybe something has changed in WSL.
Okay, first of all, so let's talk about some typical common mistakes. Did you download free educational version of Govin or commercial version?
That was my first question. During through instructions, I realized that wait, Govin is not actually mentioned anywhere. Can you check? Can you show me where you mentioned that?
Okay, so first of all, in that instruction, I assume that person already installed Govin.
I see.
So
Okay.
so first of all, you need to get a Govin ID download, and you need to download Govin ID. So
It's just I was checking through the release and
yeah.
made me aware how to install Intel toolchain, Quarkus, and WSL, but none of them were Govin.
Yeah, so we do have, so if you look to my email, so let's go to Google Groups email that I did mention place with instruction how to install Govin. So let me show you the place. 1 second. Okay, yes, another instruction and info on plan. So if you go to, no, it's not here. So recommendation for new members. Let's see this. Yeah. So this is email from 8/18. I'm not sure if I added you here, but okay. The main topic is preparing new release. Spreadsheet, slides. Yeah, so this is instruction about Golang. So if you are member of this group, and you are, there is instruction of how to install Golang. So how to install Golang? So installation of Golang EDA. So you go to.
So was it intentional not to put it into GitHub?
The problem is the person who wrote it, he wrote it actually a long time ago, like a half a year ago. But he wanted to like edit it, and I started to edit, but then I was busy with something else, so this never was finished, and he never actually published it. And now he's busy with some commercial project. But instead of this, we actually asked Govin Marketing to create instruction for us. So they are now working on it. So we have a good instruction. If you want, you can put short instruction, but basically you can follow instruction I put in my email like last week. But before, you need to install Govin EDA, and to install Govin EDA is very simple. So you just go to Govin website, and you register on Govin website, like register or Govin login. So let me do login. So this is CMSD. So you go to member area, and then you go to products, then you go to Govin EDA, and then in a going EDA, you can going EDA download. Yeah.
Looks like a boss following instructions, but their own instructions.
Yeah. So here there is a software for Linux and software for Windows. So while our scripts do work together with both the commercial and educational version, so but I recommend educational version because we actually run all boards with educational version except for board 10 Mega 138K Pro. So this is a big board. I have this big board. But you can use educational version or you can use commercial version. But for commercial version, you should get license from them. So you should request for license, and they will give you a license. Yeah. So you need to install this into. You need to install, and once you have this installed, you also need to install like under Linux tool called OpenFPGA Loader. And this is available for some Linux distributions as a package. So you can just put like sudo apt-get install OpenFPGA loader, and it will install it for you. But if it's not, you just download it as a source code and build it. So it builds no problem. Yeah, so this is how to install it for Linux. For Windows, it's even more easy. You just get Windows version, and with the Windows, you don't need to install OpenFPGA loader because with with Windows it uses Govin tool to like upload something to FPGA. Because with the Linux, their own tool has bugs, so we decided to just use So we decided just to use Open FPGA loader for Linux. So now, once you install all the tools, then you can follow instruction I put last week for going person. This instruction is notes on using basics graphic music repo under Linux and Windows. So once you install everything, under Windows you need to use git bash, but if you use Linux you don't need anything except for going ID. So all you need to do is that you need to git clone, git check out new graphics, and then you just go to a repository and you run synthesize script. That's it. Yeah. Hey.
Question. I tried to look for Yuri Pancho with music and graphic on Git, and I was not able to find it. Maybe is it private or public?
No, it's a public.
Interesting.
Yeah, Yuri Pancho, basics, graphics, music.
Yeah. I found another guy. He cloned. It seems like your repository, but not you. Okay, yeah, that's fine.
Yeah, so you need to find Yuri Pancho. But who did you find?
Some David or something. It's probably it looked like someone just cloned.
So this was just a fork, right?
Yeah, fork.
Yeah, okay. Yeah, this is fine. So when you clone from fork, you should be able to get it, but his might be out of date or something. Yes. Anyway, yeah.
I think the second repository is homework.
Yeah, homework.
Wasn't in English. Yeah.
Oh.
It wasn't.
Human instruction. Yeah, I have to. I want somebody to actually write instruction in English, because initially I was using this in seminar like in Russian-speaking countries. So I went to like many of them. So like Russia, Ukraine, Kazakhstan, Kyrgyzia, Georgia, Armenia, Azerbaijan, and now I'm actually discussing about going to Uzbekistan. So I can make a full trip to 15 republics eventually. But basically here, all you have to do is that you have to go to a repository and you have to install Icarus Verilog and GTK Wave, and then you just go to repository and you go to like 0-1 combinational logic and you run just one script, which is run all using this one. So script called run all using iVerilog on the Linux or Mac OS Brew, and that's it.
And what you will do?
And so basically here you have like many files, and each file has some task to do. So it shows that you have like multiplexer max, and you like as an example, it chooses between like two pieces of data, and you need to create multiplexer which chooses 4 pieces of data. Yeah. Now I want somebody to write instruction here in English. Just I don't want to do this myself because I have 100 other things to write, and I just want to give it to somebody which can be used for his own education as well. So he just does it and writes an instruction, because here the whole instruction is that you clone this, you install Icarus Verilog and GTK Wave, then you go to combinational logic, you run one script, and then you modify it, and that's it.
Yeah. It's harder than sound.
Well, if you want, you can just first of all, this the repository has a private and public version. So we have also private version. In private, there is a script which automatically generates public version, because in private it has solutions. For example, here it has a start solution and solution. So this script actually removes code between start solution and end solution and generates code for the public repository. So if you want to take part in maintaining it, I can give you access to private repository, and you can write instruction in English, so which is in like MD format. But just I want to use such as opportunity for somebody to practice in like writing MD document and so on. You know?
So you have a Russian version already, or
Yeah. So here there is the Russian version. So this is the Russian version. So this is repo. And there is the Russian version. This is the Russian version.
No English version.
And there is no English version. So we want to put here English version, and with the same code. So this for both like Linux, Windows, and Mac OS. But as I said, this instruction is a very straightforward. As this was,
I can help with the porting.
yeah,
Um,
sure. So you can because let me So what you do is that you just fork a repository, and then you do a pull request. Yeah. So basically, if you want, you can use like a Google Translate to translate this from Russian, because everything here is a very straightforward. But the problem is that this is a little bit obsolete. Like you need to put, for example, a new version of no, Harris book is a new version. So just you can create a new MD file and make a link to this MD file in Russian. So put just like readme Russian MD and put link here on the top, so that here is the link to the file in Russian. Yeah. And that's it. Yeah. So just like please, if you can do it, please do it. Because the problem is that like right now, what I'm trying to do is that I ask several people to modify support for many different boards, and basically I have to review what they're doing, because in many cases they're making mistakes, and then like the review of those boards, so I'm like swamped with the things. So if somebody can like offload some activity, this is a great way to like offload, because Yeah,
to read the
thank you, thank you. Yeah,
Might have-
you have to read the manual. Yeah. Okay. So this is this part. Okay. Yeah. Mhm.
So when I try to use it, stuff on Windows, as it turns out, there is a WSL and just normal Windows bash files. And seemingly both are kind of supported in different ways. So what do we use?
Wait. What window are you talking about?
So in the
So you're talking about homework, or you're talking about basics? Yeah. Sure.
it explains how to install Intel Purpose,
Yeah.
how to use WSL,
Yeah.
and something else. So seemingly Windows does support bash files. Does it mean that we should use WinStall as a
No. First of all, no. Don't use the WSL. So initially, like a year ago, I wanted to support WSL, and I asked one person to implement support for WSL. But unfortunately, this person was doing it not a complete thing to the end, but he was trying something partially, and it partially worked. And when I looked at what he did, he actually did like didn't put quotations everywhere, didn't properly process backslashes and many other things. So finally, because we like didn't have time and they wanted to have a stable repo, I said that okay, let's forget about WSL completely. And I even created error message, which is now bash script is trying to figure out whether it's run under WSL, and if it is, it says that either run it under Linux or under straight Windows.
I see. You just your WSL instructions are still there.
Yeah,
I tried to follow them.
this is not mine. I didn't test it. I didn't even look at it.
Okay. Okay.
So it's there. I have no idea what is it. I never read a single line of it. So for running under Windows, the standard, if you want to take care of WSL, you're welcome.
Yes, I was trying to follow different kinds of instructions, and looks like all the instructions I tried to follow,
Yeah.
all on the wrong set of instructions.
Yeah.
Like
So
WSL
don't blame me. This is not a bug. This is a feature. I made this as a feature that I'm using this chaos so that people can show me that they can accomplish the task.
No, my question. Yeah.
Okay. Now, the thing which works reliably, what works is running this under Windows and running this under Linux. And under Windows, we are using bash under Git for Windows bash. So under Windows, there is a product called Git for Windows. So if you look to my notes, so what I'm saying here is there is a product called Git for Windows, so you can download it from here. Yeah, and when you download this product, it also, in addition to Git, it also installs bash. However, when you install bash, yeah, and you can install it in a default way, but if you install it in default way, you need to open a bash window to like enter scripts with like a bash terminal. But if you want to run bash scripts from regular command line or within VS Code, when you install, you need to click option use Git and option are Unix tools from the command prompt, or you can get from a command line and also third party source. So you need to click this option, and after you click this option, you can run bash scripts from Windows command line.
Interesting. Maybe alternative option would be running PowerShell, right? Under Windows, we use PowerShell to run SH.
PowerShell. If you associate SH, first of all, PowerShell does not run bash. It's for sure.
Okay.
But PowerShell can load bash interpreter run your file if you associate .bash with git with a git bash. Then you can write just a name. But if you don't associate, you can still run it in a way bash script name. So you can still do that.
Calling the bash program.
Yeah, so you just call bash and bash runs your script. And that's it. But also I noticed that during installation you can give an option to installer that you want to like associate bash exe with .sh files. The only problem is that all scripts are called not .sh but .bash. Because I always assume that .sh must be POSIX shell. And in the script, we are using many bashisms, so bash specific things. So, and because doing that just pure POSIX shell would be like less nice, so I decided to call it .bash, and .bash does not have default association with bash. So you need to put this association yourself, or you can use it by bash script name. Yeah.
I just installed VS Code and Git started to work.
Yeah.
I was able to check out that doing anything special as far as Gambel. I'll investigate.
Yeah. So now since you mentioned WSL, let me first time in my life actually read it, because I didn't do this before. I had to read it, but I was busy with something else. So like another member, he checked this in.
Okay.
No, but let's see what is there, because I already forgot. Okay, so what is there? So okay, reference document.
Branch just in case.
Yeah, you also need to switch to.
Why well?
Yeah, okay.
To new graphics.
Yeah. Okay, so now let's see what is here. So download and install. Okay, you can install WSL. So I believe that under WSL you need to use Linux versions of IDE tools rather than Windows versions. Because the problem is that WSL in principle can run both Windows executable and Linux executable. But if you run Quartus under WSL, if you run Windows executable, it gets confused. So you need to use Linux executable. But for other programs, so that's why I never really care to use.
Unrelated to everything we have done before, right? Because
Quartus is a for Altera board. Yeah, not for Goyen. For Goyen, I have no idea how Goyen runs under WSL. I never tried it under WSL. You can try. I want somebody to try. This is not okay. Basically, my goal is to make sure it runs under every environment. So if you want, if you like to use WSL, no, I want you to have preference. If you usually use WSL, I want you to take charge and make sure that it's compatible with the WSL.
I do not have any other Intel CPU in my house except Windows machine.
Okay.
I usually don't use Windows, so it's challenging.
So now.
Yeah.
So now it's putting sudoers, Windows as administrator. Oh, it's all complicated. So you need to use USB ID. Yeah, so you need to install OpenFPGA loader. Okay, yeah, it needs to install OpenFPGA. Yeah, okay. Yeah, so this is instructions for Goyen. So who actually put it? I already forgot. Let's see. Okay, so two. It was Dmitry. Okay, so yeah, so he put it, but I never actually tried this myself.
Yeah, this instruction is
So yeah. So this instruction is just there, but don't really follow it. So now because I was working with the Gorin on making this Maker Faire seminar in the future, their marketing person is now working on instructions. So hopefully you're going to have a decent instruction before October for Gorin at least. For Altera and Xilinx, there are some instructions, but as I said that I intentionally want other people to write instructions. You know,
This WSL4, it's like whatever, like just on a high level.
WSL is a Windows subsystem for Linux. It's a Microsoft version of Ubuntu running as part of Windows.
Inside Windows, right?
No, not a double. So you can just run it as a part together. Yeah, this
It's not a virtual machine. It shares the kernel, so that's why it's faster. But it doesn't have support for a lot of things.
so this like needs
No, that sounds familiar stuff. But
the bash tool
Another-
for Windows, it uses Sigwin on the boot, I think.
no. This is not a Sigwin. This is Bash. Bash use not Sigwin, but another one. There is a competitor to Sigwin. Let me tell you the name of this thing. So okay, so Sigwin alternative. I was using Sigwin. I was using Sigwin back in like yeah. So it uses min GW.
Yep.
So it uses min GW. Yeah, and there was also M system. Yeah, but min GW is a little bit better than Sigwin, but they are sort of all the same. So they are trying to work around the fact that Windows uses backslash and Linux uses forward slash, and because of it, there are many like small problems everywhere, and with symbolic links and stuff. And basically because I didn't want to like I didn't. But the most evil part about WSL, this is why I really hate Microsoft. You know, like 30 years ago, when Borland made a new version of compiler, which was a 32-bit rather than 16-bit, and they put memory extender for 32-bit. So there was 16-bit Windows, and they wanted to put 32-bit, so they did DOS extender. This was back in like 1992 or something. So, and when Borland made this memory utility, Microsoft put a new version of Microsoft compiler, which uses another memory utility, which made Borland cache. So you had to have two auto-exec bat files. One runs, one put into pass Borland, another put into Microsoft, because if you put into config sys Microsoft stuff, it caches Borland. So same thing Microsoft did here. So Microsoft, when you run WSL, it pretends it's true Linux.
In a way, it's binary compatible.
No, but it's not true, because you see, the problem is that when you are trying to figure out what operating system it is, it tells it's true Linux, and then it has some incompatibilities. So now, for this reason, what I did, I detect this is WSL. So it has like OS type. When you ask OS type, it tells Linux GNU. Yeah, so this is protection against running WSL. So basically, it tells us this is Linux GNU, but then when you run some stuff, it does not behave like a Linux. So there are some differences. So for this reason, I detected by checking variable WSL distro name and says that you're not running under true Linux, but under Windows subsystem for Linux. And so we don't support right now. So if you choose to use Windows, download from git4windows.org and make sure to bash from git is in Windows pass and so on. So the reason I did this was that some bash things were behaving not in true Linux way. So I found such problems, then to prevent it. But if you like to use WSL, please, but just change it to make it compatible. This is just one of those things which is easy to do. Just person who says that he will do it, didn't do it for 3 months, and then said, okay, we cannot afford to have something which sort of works, and then people complain.
Just use a VM, not the problem.
So you want to use true Linux.
VM,
But you can use true Windows. It runs under true Windows as well.
I'm not very particular about what kind of tools that I use.
Just VM has other problems. VM has a problem with the USB pass-throughs, and this has a problem for Altera. But if it runs, if you run problem with Govin, then I cannot help it because I personally I don't like VM, so I'm trying to like avoid it. No, my recommendation is that recommendation is just use Windows as is and use Bash for GitHub.
Or use Linux, right?
Yes. Anyway, we do have laptops today. Okay. So now, Kevin. So what did you try to do recently?
Making a few more questions on the system Verilog homework.
Yeah. Okay.
This board on Mac.
Okay.
I was a little lost on how to do it, so I gave up after about 30 minutes.
So, but did you try to create virtual machine on the Mac or?
No, I searched online for ways to run Nano 9K.
Mhm.
I think there was one where there was already tool chain.
Yeah, there was a USS-based tool chain. Yeah. Yeah. Lush Labs. So Lush Labs is the guy who created a set of examples. Yeah. But actually, a person who involved in USS told me that it doesn't matter. So he was, so he supposed like USS toolchain, and if you can make it working on Mac with USS toolchain, this is actually great. But just 2 or 3 days ago, I heard that there is some bug in recent version, so this might be difficult. But anyway, I do have a recently checked in configuration what you can try, and this is called, so this is called configuration called Tang Nano 9K Govin Yosis, and this has make file which runs Yosis, so you can try, but just I never tried it myself. But if you can make it can make it work, this is something which we need badly. The only problem is that you need to replace here CST file, because this is all obsolete version. This is version main branch, and we changed version. So you need to get new CST file, and you need to rewrite board specific top. So you need to rewrite all of this, but you can look to this make file and it was used to run it on the going. So if you go to main branch, maybe you can even run it.
Main branch of what?
Main branch of the repository, because the repository has now two branches, main and has new graphics. And I'm going to merge new graphics back into main on September 15th. Because now I'm making a lot of changes in different boards on different branch called new graphics. So if you can figure out how to use it there, this is actually a big deal, because we are working straight with the president and marketing of Govin. You know that? So he's their marketing person is sitting now. I mean, this weekend he's probably taking rest, but tomorrow he will sit and work with our examples. He tried our examples last week on the Windows. On the Linux. So this week he will try on the Windows. If you can deliver to him something which works on Mac, this is big deal for them. You know, you can use it and you put it into your resume as like major project. You can ask their marketing to put you some like endorsement into your resume. You know. And to get this, because you're a recent college graduate, if like employer look, oh, he has endorsement from going marketing for accomplishing something, your chances like an offer goes high, because this is good thing. You see, like boss of my boss look for such things in the resume. Yeah. So yeah, so I highly recommend you to do this. You know,
All your examples running on my Mac, or have it so that anyone can compile
yeah,
these examples on the board.
yeah.
The Mac will be golden.
Yeah. If you can, if I were you, I would do this right away, right now, because you are in right place, right time, and you can use it to the max. That guy from like Lush Lab, I think he actually lives in Israel, and he is now in army, so he might be not very responsive. You know.
No.
Why Mac is so important for going?
No, Mike is not important. Mike is important for young
More
people.
user accessible to people who are using it, right?
Yeah.
And a lot of people use it.
But initially, by marketing targeted what? Linux only, or what?
No, initially Windows, Linux, but you see, like my wife and 3 children all use Macs. So we have like 5 Macintosh in family. So I also have extra Mac, but like I was using Mac only when I took like Photoshop classes like 15 years ago. But many like especially students do use Mac, and because Mac is a free BSD. It's essentially the same console, so you can do everything on the Mac.
At the same
Because
time,
now it moved to ARM.
Yeah,
I haven't
that's-
even attempted making it this out in the ARM, but nah,
Yeah.
have it no CPU.
even existing software might not work on that.
Like, nah. I can try that.
But
I could run the Yoast toolchain with this on the Mac.
yeah, great. This is like what I'm talking about. So now,
Because somebody told me something may be broken, so it want to patch things that could be broken.
Which product?
I don't have Intel Macs at home, so,
You just have M1.
and like,
It
it's
didn't
unlikely to anything was gonna work there, right? It's extremely unlikely.
Oh my.
so what I'm saying is that if you make everything, all these examples running on Mac, then you immediately gives Govin Semiconductor a competitive advantage against Xilinx and Altera.
Oh, wait,
That is
but
true.
we do not
You
run
know?
on Mac for sure. Xilinx,
Yeah,
That's no, and no way. Their engineers, no way. I can bet money there will be no such thing in a couple of years.
But it's interesting, and I might understand that because if you go like to real job, right, in corporate segment, right, Ubuntu everywhere, like Linux everywhere. Linux, of course.
Most of electronic companies use Red Hat this
Not bad.
corporate
Well,
edition.
like variation of
So,
Linux.
but the Macintosh as a clients for Linux are used in many companies. So both in like Juniper and in Samsung, we have option to get a
Maybe
Mac
that's right.
Mac as a client.
What is Altera is targeting like corporate segment, like Linux
No,
is enough.
you don't understand. Altera, like 3 years ago, they put educational free version on the web, where both Linux and Windows, both versions didn't work right out of box. You had to get a patch for them to work, because for Windows and for Linux they were using some like obsolete libraries. The problem is that um, my hypothesis is that they cannot get the best people for GUI, because best people want to go to Microsoft or Google. You know, so like if they go to like Altera, they're probably not the best. And as a result, they're like lazy and didn't maintain last version for like half a year. You know, and I was sending email to their manager of educational programs, and you know what he answered me? He don't. Oh, you know what? I also don't use the latest version because it's unstable. I use a 3-year-old version. This is their manager of educational programs of Altera program logic division.
Have you heard about like recent cloud outage and
CrowdStrike?
something? Yeah, and one cloud company was not vulnerable. Why?
It affected me.
Oh yeah. No. But one company survived, and we asked it, oh, what's happened?
Windows 3.1. Yeah, Windows 3.1. Okay. Now, so basically, yeah. So, but in the meantime, if you I have actually a bunch of extra computers if you want, so I can bring some like Linux box and you can use it for a Linux. So do you want? We can get it in right now. Live like 10 less than 10 minutes from here. I can. You can drop by my house. I will give you some Linux computer.
All my time is spent trying to get this,
Huh?
because you said that they need this to run on a Mac.
Yeah, but if you can make this all run on the Mac, yeah, this is like I like already explains you what it gives you. So like in resume, endorsement, competitive advantage for going. This is all very valuable, you know. Yeah, and like if you want extra Linux computer, we can just stop by my house. I live nearby.
I'll stop by.
Yeah, okay. So like after this thing, we arrive. Yeah. Okay. So what is next? Okay, yeah. Now next thing is so on next Saturday I want to make such meetup in LA, and I put all the information. So if you can send some of your friends to like UCLA, and we can sit down with them, I can actually create some little exam like with interview questions, and they can like practice on it, and they can give a review. I want to put some interview questions in form of paper and some in form of system Verilog homework and some on FPGA boards. Yeah.
School, they usually start heading back on like September 14th weekend.
So there is nobody there.
No.
Okay, yeah, but if you can find somebody, yeah.
Just know that it's not usually school time. It's not school time yet.
Yeah.
It'll be for 3 weeks until
Sure.
school starts. So.
Yeah, but this is not the last time I visit LA. So, but if you can like say somebody, yeah, this is a great. Yeah, so like if like a couple more people can come, this is like great, because we got because like the girl I asked to rent a room got room which is too large, and if just a few people come, this will look weird. you know, because so for this reason I want to get more people. Yeah, like I should tell her to get smaller room. So yeah, now okay, so um, now like let me actually give you some like a laptop right now, and huh?
Pressure list.
Yeah, so you can try this one. Yeah, if you can send give like professor list and send them like emails. Yeah, this is great because I can also invite them and tell that doesn't you know what my son is starting education and by the way wait you go yeah is this one right? Oh, what is it? Because it's another one. Ah, yeah. This actually a little bit nicer, but if somebody want like either one, so do you need? This is another one. So those are two laptops. I have like extra two laptops. Yes, another is too low power. Yes. Anyway, so what we can do? Okay, and what did you try to do?
So I started to learn like some literature, reading docs, and trying to like
Mhm.
take a first grasp. And yeah, I figured out that it's more interesting area than I first thought. So
Mhm.
basically, it's like endless possibilities. Kind of, you can do a lot of things and like design. And I was surprised that number of application is huge, and there are some cases where using a PPA is even better than like using instead of on CPU, like
Mhm.
something like Raspberry.
Yeah.
Yeah, started to learn, and I asked it about its installation instructions. So it seems like you just showed on the screen, right? So it's stuff like, and yeah, I plan to after today's class, I plan to try to install Linux and
So do you have a Linux computer?
yeah, this is Linux.
Okay, so you can try to like install it right now and you can test it on your system. Yep.
I just was worried that it will take time or like
No, you can do it in parallel because my plan for today is the following. My plan for today is that we implemented support for several boards, so now I need to test boards. And I want you to help me to test boards. And by testing boards, you also go through the examples. Okay? So now, what we can do is that, like everybody, okay. So like, you can install Gorin toolchain.
I
according
would
to
better like focus on helping you testing if you have like
Yeah, but you need to first install it. Yeah, I have a bunch of boards to test. But so what I want to do, I want to give everybody board and then just to go with me through all exercises and see whether something breaks or does not behave. So we can go one exercise after another exercise. Yeah. So, Kevin, so what do you want to do? So, do you want to try to take part in like testing boards or to what? So you can. Ah, wait. This one has a quartus. Let's actually go through. So what? You can actually test quartus. Yeah. So you can get this board. So get this board.
Assembled too. So.
This board, like everything is assembled here. You just need to connect a screen. So let me give you a screen.
Over here. This one.
Huh? Ah, no, not this screen. For this one, you need this screen. So this one. This is a VGA screen because this is like older board, so it uses VGA. So now let me give some board to you, so you can actually test. You can actually test the board support what Pete was doing. So let me give you board here. So it's a D1 board. Yeah, so it's this one. Okay, so you can,
And you can
Is this-
this up, right?
yeah, you can use this laptop. So you have laptop, you have laptop. You will install sync on your, and you will test Megaboard.
Create the pull request for the translation.
Good, good, good. Wait, so did you create translation already?
Yeah.
Oh, good, excellent. Let me, yeah,
Yuri,
uh,
can you
let
have
me,
a spare laptop, because this on the internet is very slow. It's like downloading 20 MB like 10 minutes already.
oh, if you want to install, I can give you SSD. I can give you SSD. Yeah, the problem is that I have I brought only two laptops. I have actually this laptop, but this is very slow laptop with two megabyte with two gigabytes of memory. So, but you can, yes, it does. So we can test whether it works on a computer with 2 gigabyte memory.
Yeah, stress test.
Yeah, this is
Sure.
stress test. So let's do stress test first. So we will do stress for you, and but stress test you can do it with a Govin, or you can use Altera. Oh, okay. Let me give you another. Yeah, I have a SSD which has tools on it. Just a moment. Oh, wait. You want to boot from SSD?
I don't know, like, it's up to you.
So do you want to
Fine.
test it? You can test it on the Windows.
Sounds good.
So let's test it on the
Well, it works
Windows.
good.
Yeah, Windows works. So test it on the Windows. So now, let me give you another board, which is on dashboard. It is in dashboard. So let's all of us now test examples. 1 second, where is on dashboard? Yeah. So this one is on dashboard. We can test on dashboard.
I'm looking for a power supply extender or something.
Yeah, let me give you power supply extender. Just a second. So now we will do review and test everything. And if something doesn't work, you tell me. And by doing this, we also look inside code, and we also look what is going on inside. So now everybody get a board and starts doing testing. So now for you, okay, let's see. Problem. Have to get extra computer. Yes, the problem is I don't have any more extra computers. So yeah, but you can now try to use the system Verilog homework. Yeah, and just like I will review how much you can do. So now, so let's everybody start from very first exercise. Let's everybody start from very first exercise, and let's test Altera boards today. So we have this board which requires testing, we have that board which requires testing, we have this board which requires testing. Yeah. G0CV. So now we will at the same time go through all examples and observe that they should behave all properly. So now, before doing this, I will git pull. Okay, so now let's see. Like I will make sure that I updated all board specific top. So this is board specific top. I updated recent. Yeah, so this is some DAS, git log.
Any chance you have a USB hub?
Ah, yes, I do have a bunch of USB hubs. This is specifically for this purpose. I do have USB hub. So here I have even powered USB hub.
Yeah, power.
Yeah.
Okay.
So does anybody else need USB hub? So Pete, did you implement the D2 or not yet? Yeah, okay, good, thank you. Okay, so Amdas, yeah, Amdas is ready to be tested, and the D0CV is ready to be tested. I wanted to review it with the person who did the port, but this person didn't come today. Yeah. His person from Apple, so I did a lot of changes. Yeah. So we have D0CV, we have OMDAS, and we have D1. So D1, this is something we did together with Pete. So Pete was doing it. Okay. Now, first we need to do git pull on all laptops. So first we need to do git pull, and if internet doesn't work,
I can check yeah.
yeah, so does it do git pull if it slow, but hopefully it will do it. They actually have a faster way to connect to internet with a password. I will give you the password. Here we also need to do git pull.
Yeah, if you have got this one is very
Yeah, so just a moment. I need to find my password. Hacker Dojo password. So now we will go through all examples. One second, stop share screen. Oh, wait, not a git password, a hacker Dojo password. Okay, so hacker Dojo login. Yeah, I will get a password for their fast internet in just a moment. Okay. Login using email link. 1 second. Okay. Okay. So I will give you password in just a moment. Okay. So now settings count. Yeah, this is the password. 93373. Yeah, this is internet access pin.
Looks so short for WPA2 standard.
What's the username?
It's a hacker dojo. Wait a second. This is internet access pin. Huh? So this board is called D0CV. It has a name of it. Yeah, this one, 10. D0CV. So, but try hacker dodge and try this pin.
And do you know, this one I just typed and it does nothing.
No, not free, just regular. Oh, it doesn't have it. It has only free.
Okay, where is Hacker Dojo?
Yeah,
Right?
hacker dodge. Yes, enter.
I type, do nothing. Maybe weird Linux thing.
I don't know.
Yeah.
So is it connected?
It's connected to free, I guess, maybe. Right now.
So maybe you need to disconnect from free.
Oh, okay. TV plus. Oh, okay.
No, I cannot help you here because I need to do something here. Okay, so did you were you able to get pull?
Yep.
Yes, after great, excellent. Okay, so this board is called D1. Okay, so now let's see. So you did a git pull right here.
Oh, I didn't do that.
Yeah, you need to do a git pull because otherwise D0 for D0C I implemented only yesterday, so you need to do a git pull.
Basic graphic music, right? Graphic music.
Yeah.
It exists, maybe it's.
Yeah, just do a git pull.
Yeah.
Oh, excellent. So we're in good shape. Okay, so now you turn this on.
Mhm.
So your board is up and running. Your board is up and running. So everybody's board is up and but a git pull. So did you do a git pull? It's doing right. Okay. If it's too slow, you can use that like password for access.
I can't tell how long it's gonna be.
Yeah, hopefully
like
it's not that slow.
20 seconds.
Okay. Huh?
It's touch screen.
Oh, okay.
It's like
Yeah. Okay. Let me get water. Let's start doing this. Yeah. So now while this happen, I can get a pull request. First of all,
Why should it be USB or single?
Ah,
I mean, the FTTY, that should be serial or USB? I don't.
what?
I mean,
No,
serial
no,
connection.
don't mess with it.
Oh, okay, okay.
Yeah, it's all completely automatic. So do
Okay.
CD labs.
Uh-huh.
Yeah.
Uh-huh.
And then go to one basics,
Okay.
one underscore basics. And then go CD101, CD101 tab. You see, yeah, okay, yes, enter. And then here do slash 06 tab, 06 tab, yeah, enter. So choose the board called AMDAS 33. Oh no, you can choose RD. So there is the RD. No, RD. Yeah, you need to scroll up. No,
Okay.
okay. So just scroll this way.
Okay.
Okay, so RD number 39.
Okay. 39.
Yeah, enter. Okay, good. Now ./03 to synthesize. Yeah, yes, enter. So now let's see whether it synthesizes and correctly configures. So same thing here.
So what is the first? It's choose a PG, right?
Yeah, so choose FPGA board. Yeah. No, don't configure. Enter. Mhm.
It says something Altera cannot be found.
Okay, let's see. First of all, did you choose a board?
That's what I've tried. No, it's 6.
So
Which one?
zero. So you need to do bash or like bash 06. Okay. So and this is D1. So you choose D1, right?
Yep.
So you choose D1. Okay.
16, yeah.
So which is 16. And you think, oh, okay, choose expected to find Altera. So this means that Altera is not installed there. So let's see what is installed. I thought that I installed everything here. Okay, let's see what, because this one uses older version of toolchain. So let's see what is installed. If it has only new version of toolchain, then you can use that board and here
Maybe you
use
have an
this board.
SSD?
Yes, I have it. You can install it if you want, like older version of
That also
toolchain.
works.
Yeah. So this one has yes, this doesn't have older version of toolchain. So let's install older version of toolchain. Why not?
Okay. How do I do that?
And it's very easy. Just a second. But maybe this already has. Okay. First of all, how much space does it have? Does it have enough space? One second. Space available 71 gigabyte, more than enough. So let's close this one. Interesting. Oh, yeah, it has what it has it here, like Altera. Yeah, so just get. So this is just get this older version. This one is the old version of installer, and there are two old versions. One is 13.0 and another is 13.1. So let's get 13.0 and test it under 13.0.
Okay. Just run this one and go to the
Yeah. Just but copy it into temporary directory. I want just to keep this intact. Just copy it in some like temporary place, then unzip it and then run installer.
Okay, can do.
Okay. Now let's see. Okay, let's see. Oh, seriously?
And I swapped to Terry.
Just a second. This is weird. Oh, yeah, found oh, but this found old quarters. This is 13.0. I'm not even sure if this board is support. What one? What? Wait, this is lab. Oh, What?
With 17.
Oh, but let's use different lab. This lab I didn't even try. Let's go from here.
216.
Let's go to lab. Wait. You need to switch to a different branch because this is branch called main. And you need to switch to branch in new graphics. Okay, so first of all, what yeah, so just do git switch new underscore graphics. Yes.
Okay, then go to the original.
Oh, excellent. Now go to one basics. Oh, before this, let's actually clean like all the like unnecessary thing. Do git clean, and then do git clean, then dot dash d. So git clean. No, not a dash. Dash, not slash. Dash. So clean. Yeah. No. Space. Okay. Clean dot space dash d, and then space dash x. So hidden space dash n enter. So this shows you what is going to clean. So it's going to clean these directories which are not part of new branch. So do now go this up and then put dash f instead of dash n. So dash f means force. Okay, so now wait. Deletion of directory failed. So you have open file somewhere. Okay. Yeah, so let's go to different directories there.
Okay. I've never done this on the actual GUI.
Here you can do now n, or you can like open different directory. Yeah, so it removes this is fine. Okay, so now let's cd one basics. Okay, enter. Okay. Now go to cd 101 whatever. Yeah, tab. Yeah, okay, enter. Okay, ls. And now you can choose the board and run example. So it's just 03. You choose board, and this board is called. So you're saying this board is correct. So if you do here bash and file name, it will run everything inside here. So it will not run in separate window. So it starts in separate window when you do it in this way.
Okay.
But if you do bash something, then like you can read what it says in the log. This is because it's Windows. Yeah, so this is Quartus. Okay. Now I will do the same thing. And now let's just, so first I recommend to see what is inside the example. So let's actually do this together now. So you now slowly run all examples and make sure that it does what it's supposed to do. Okay, so now I will do it in with my, oh, let me actually run it inside VS Code. But I'm not sure that VS Code will work on that little computer because little computer has only 2 gigabytes of memory. Yeah, VS Code may actually crash there. I tried it. Okay, so now let's do git pull up already up to date. So first we are going to directory called 101 and or not XOR D Morgan. And you can, so let me first synthesize it. So first I choose another FPGA board, and in my case it's D0. So which is board number 10. Then I do synthesize. Okay, so how is your installation going?
It's doing its thing.
Yeah, it will be for a long time.
Yep.
It's complete here, you need, how can I?
Okay, so now you look to the code and then you can see that like you can test with those buttons. So
Yeah,
you
I
look
tried
to the code and yeah. So now you can actually go there. Or let me show on my computer what I'm doing with the board. So you go through the code. You go through the code and you can see what we are doing here. Okay, so if you look inside the code, or if you want, you can switch boards. I think maybe he has already installed. So let's see what tool chains do you have here already installed, because maybe you have already both new and old tool chain.
This code works, doesn't crash.
Good, yeah. So this is computer with 2 GB of memory, so very old one. So now let's see what is installed here. So no, like I'm looking for the tool chain. So I think this has InterFPGA, but does it have Altera? No, it doesn't. Yes, alternative thing, you can use a boot disk if you don't want to wait. So do you want to boot from a Linux disk?
I mean, it's almost there, no?
It will take some time.
I don't mind. I don't mind either way.
Okay, this is fine. So let's test it on the Windows and let's install all the tool chain, which is fine. Okay, so now if you look inside this example has a module. So Kevin, yeah. So what I recommend you to see inside code of each example, and then figure out what it does, and then do this on the board. So this particular example, it uses keys. So what it does is that it creates wire A for key 0, wire B and assign key 1, then wire with the result of XOR, and then it puts it on LED 0, and then it also puts on LED 1 continuous assignment from key 0 and key 1. So this is very straightforward test. And now it also asks you to do some exercise, change the code below. Yeah, but for those who like already have experience with Verilog, this exercise is probably too simple, but you can do this anyway, just to test exercises. Yeah, it's up to you. So now you can see that here, when you press button 0,
Button 4. S4. S4.
no, this has different buttons. This is different board. Okay, so now does it did they synthesize it? Yes, it did. Oh, it doesn't work. Okay, so this board doesn't work.
You can show on mine. This one.
No. This is the purpose of this. The purpose to test the board. So now it doesn't work. It's just like fine. So now I need to debug this. But anyway, on his board it's working. So on his board it's all working. So
But it's different board, right?
yeah, those are different boards. Yeah.
But manufacturer thing.
This board is manufactured by Terasic, and that one by some company in China. I don't know the name. Yeah. So now like our goal is to test the board, and the fact that it's not working is fine because it just means that I need to debug why this doesn't work.
But both these boards use the same FPGA, right? Or no? Same FPGA?
Scripts, yeah, no, a different FPGA. This one uses Cyclone 2, and that one uses Cyclone 4, and that one Cyclone 5, and this one also Cyclone 2.
But we run the same script which works on this.
Yeah, but we run the same script. So script figures out what to use. So now
Any chance what selection was failing on your side?
No, there might be some like prog is failing. I will figure it out. Oh, wait a second. This one actually did work recent. So this board is actually alive, but something is wrong with the keys.
So maybe the pins are not right.
So maybe the pins are not right. So let's figure out what is wrong with the pins. Yeah, but you can actually continue to do something. So it looks like key is not correct here. So
Can you repeat the
let's.
question? How this board does work right now? It seems like previous configuration was uploaded, right? And it's still there. I mean, on your board, where you just showed it's from some previous script, right?
No, it's not. I
Oh,
just
it's not.
I just synthesized it with the new one. So when I do
Oh,
reset, so reset reset on this board is the left shift. So after reset, it put all ones into shift register, and then it pushes data out. So now, like apparently some pins are not corrected right, and let's find some warnings we have here. So the warning may be related to the fact that I renamed pin. See, pin key 0 is not assigned to the location. So this simply means that I did some mistake in the pin assignment. And I remember that I renamed this. And I do remember that I renamed key into key switch. Key. Yeah. So actually, this is now called key switch because I renamed it in QSF file as a key. Oh, wait. Oh, because it's called here button. It's not called key. It's called here button. It's not called key. Was it called button in the reference one?
no.
It was actually button. It is called button. So here it is called button. So we should rename it to button. So here is a button. Okay. So what we do here is that we replace key with a button everywhere. So here's a button, button. So on this board, key is called button. It happens. Excellent. So one bug is fixed. So we synthesize it now. Yeah, but this is different test. This is shift register test. So now we start with from example one. All right. All right. Now, yeah. See now it works. So now I press this button and it has the shift register. So we just fixed an issue. Okay. So now let's start here from the beginning. So I press synthesize. So it's actually a good that we now go through all examples and see what they do. We have enough time for it. So during like 1 hour, we'll go through all examples. And you will see, and you will understand what those examples are doing. Except for examples with sound, because for sound, we need to connect some extra microphones here, but we need to connect them anyway. So you do this at the end. But let's do all examples except sound.
And Dota Suite system Verilog and QSF stands for.
QSM is Altera specific signal mapping. So now we press this button and we can see that LED is on. So this is XOR, LED is on. And if you press both of them, it's off. This is exclusive one. Next test. Next test is a multiplexer. So what is a multiplexer? Multiplexer is a simple is a hardware if. So we can implement multiplexer in 5 different ways. So one way is that if it's selected, it's A, otherwise it is B. Another way. So yes, another way is that we have another way is using if syntax. So we can do multiplexer using always comp, which is the always work for combinational logic. And we have if, so you need to read in the book what this always comp means. And another way is always comp and case. And another way is that it's exercise for the user to implement using logic operation. And then there are many ways to implement using tables. So you can use like lookup table, and you can put a bit vector of constants using wire, or you can do it this way, or you can put or you can assign in this way and then use selector, and there are several others. So here basically it's same thing using different syntax. Yeah. So it's like testing for features. Okay, so now we synthesize. So let's synthesize this multiplexer. Yeah, so try it on your board. Yeah. So then you can just quickly try it on your board once you install everything. By the way, if you are interested in like in Altera boards, I have two extra boards I can loan, so you can get such board and try it as well.
Last week?
Yeah, last week it's a 10 Nano 9. So did you get one? Okay, so you can get it today, but I want actually to use it in LA. So yeah. Now, okay, so now here we are using 3 buttons. So we are using three buttons. So one, but actually I got 10 more. So I can loan one of 10 nano. Okay, so we are using key 0, key 1, key 2. So now this is key 0, key 1, key 2. So key 0 is B, so we're using selector. This is selector, and this is when we press 1, it selects key. So when we press key 2, which is a selector, if you don't press it, it's like 0, so it selects key from here, and if you press it, it selects key from here. Yeah, so this is a multiplexer. A multiplexer works. Okay, next, decoder. So let's synthesize decoder. Decoder is a special construct. Oh, sorry, this is test bench. So decoder is a special construct which converts a number into a bit vector which has a 1 in the position of this number. So if number is 0, you have 1 at position 0. If number is 1, you have 1 at position 1. If number is 2, is 1 on position 2, and so on. And here is a different way. It's not a decimal to binary because those are still binary numbers, but this is from a binary number to a position. So this is a decoder from a binary number to a position. Decoders are frequently used, including in multiplexers, because in multiplexer is essentially a combination of a decoder and a selector. So those are some basic components all engineers should know. And we can show how they look in schematics. So if we like synthesize the thing, you can also run GUI, and in GUI you can so here we have error.
Why you run for ASIC?
Oh yes, I accidentally ran for ASIC. Sorry. Yeah, so now we run synthesis for FPGA. So now you can try this example on your board. Okay, so now we can see that light is the position 0, but if you press a button which is 1, it's a position 1, and then when you press this button, position 2, and when you press this button, it's a position 3. And if you press anything more, okay, 4, it doesn't do anything, 5, it doesn't do anything. Okay, so this is a decoder. So decoder is one of basic elements. Now, if you do run GUI, so this is something what I also want you to try. So we can run GUI. And if you run GUI, we can do the same thing in a GUI. So this is older version of Altera Quartus. We can do compile design here. Okay. So now, if you click to RTL viewer, so you can see that this is a GUI. You can click on laptop, and you can see that it implemented decoder. So you see, this code is understood by synthesis software, and it just implements a decoder here.
Wow. So it's from .sc file, right? It's parsed
Yes, it parsed the .sv file. So now you can see actual schematics it implemented. So it recognizes that this is a decoder.
Nice. Is there a way to do vice versa, like draw it in this ID?
Yes, there were. Yeah, you can actually draw schematics in GUI, in Quarkus GUI, and you can like.
Like,
It is a completely precise, but this is very labor intensive. People generally don't draw schematics in GUI since like 1993, so for last like 30 years. Yeah, now if you go here to technology map viewer, you can see Opa. Second. Yeah. So now you can, it shows this logic mapped to its internal primitives. Yeah, but now it's difficult to figure out what it is. And then you can go to filter, place and route, and you can go to chip planner. Yeah, let's actually put screen share for this because I'm recording it. Yeah, so you can see a chip planner, and you can see in chip planner the exact you can see it. You can see like even logic here. You see?
and what chip planner
something
means?
like
Does
this.
it like reflects entire FPGA?
Yeah, a chip planner just shows what is inside the FPGA cells, inside the CLB, inside the FPGA cells. Okay, so now I think somebody is not on mute. Yeah, check. Yes, Jim, I think you're not on mute because I can hear background noise.
you should press solve.
Yeah. So you can actually ask to.
I guess you need to first reclaim the host and then you can.
Wait. Yes, because actually host on the phone. Yeah. Let me actually mute here. Yeah. So now. Yeah. Okay. Now. Okay. So now. Okay. So now. If you synthesize like something else, let's synthesize like multiplexer. So in multiplexer, if you can also run GUI, and so you can see how it synthesized multiplexer. This is actually a very useful exercise to see how synthesis tool synthesizes different constructs.
Different tools for doing different.
Synthesis tool, how synthesis tool synthesizes different constructs.
Oh.
Yeah. Like different pieces of code. So unfortunately, Altera is slower than going, but Xilinx is even more slow.
Oh, Xilinx is even more slow?
Yeah.
And last week we used does it have also GUI?
Yes, it does, but there is some bug in script. So this is a tab, so you can see that it synthesized here multiplexer. So max, so this is a multiplexer, but it also put here selector for data. Yeah, so some combination of multiplexers and decoders.
And these schematics which we just showed, I assume it also has a standard, right, for how to draw.
Yeah, and actually it has multiple standards. There's the US and the European standard. So
the name of the standard, if you remember.
So here is the US standard it uses. Yeah, but it doesn't matter because
How does it sound like if I would like look, it's like schematics?
yeah, so we can just you can just Google it.
I assume like
Git schematic standard Wikipedia.
you might want
Yeah, so if you go to like logic gate, if you go to like or gate, for example, symbol. So logic gate symbol. So there is a DIN symbol and there is the IEC symbol. There is like ANSI like ANSI standard. There is ANSI standard. Yeah, so this is military ANSI symbol, and this is IEC symbol. And this is the DIN symbol. So this symbol is deprecated, not used anymore. This is used in Europe, but in all practical purposes, even in Europe, they now use ANSI symbol. So this is ANSI
what
symbol.
we just saw in Altera was ANSI.
Yes, so it was ANSI symbols. Yeah. Now next item is called priority encoder. So those are just some building blocks which people which like engineers usually need to know, because based on those blocks you can have some like intuition about timing. So priority encoder is just logic which decides which symbol to use. I mean, like it's just like one with the highest priority. So actually, priority encoder, like if you have like 0, 1, and 2, if you have like 1 on, it will show you like 1 unless second is on. So usually I need to read it. I don't want to like explain priority encoders right now. I just want to check whether it works. Okay, so now let me check whether it works. Let me just synthesize it and check that it works on the board. Yeah, I just want to go this fast because then we need to check whether graphics works and 5-4 in CPU, so things like that. Okay, so basically here, if you press this button, shows nothing. If you press, so for 0, it shows nothing. If you press this button, shows 1. If you press this button, it shows 2. If you press both buttons, it shows 1 because 1 has higher priority. If you press all 3 of them, it shows nothing because 0 has highest priority. So 0 has highest priority, the second priority is the third priority. But if you press 0, it does not show anything. So this is a priority logic. Now 7-segment letter. So for 7-segment letter, it shows letter on a 7-segment display. So 7-segment display is the signal A, B, C, D, E, F, G, H. And basically, it displays letter on the 7-segment display. Okay. So now you can specify different letters using enum syntax with like 8-bit vector. So you can see that F is 1 at A position, which is in here. So this is F, and then 1 at E position, 1 at F position, and 1 at G position, and H is a dot. Okay, so now second exercise is that you synthesize this one letter on a 7-segment display.
Yuri?
Okay, yeah, so this shows letter F. But if you press a button, it shows in different position. And if you press this button, so if you press this button, shows P. And if you press this button, shows different position. If you press both, it's P on different position. This is like multiplex. This is how to display a single letter on 7-segment display. Okay. So next is a binary counter. So this is syntax for a binary counter. So for binary counter, you have just like this counter, and every time clock changes from 0 to 1, it adds +1, and then we display on LED left part of this binary counter. So let's see. And then there is exercise about key-controlled binary counter. Let's start this first. So it's useful if you are really new at Verilog to just go through all this code and see what it does on the board, because then you can memorize syntax. Yeah, but you can do the same thing in parallel with your board.
Yeah, it's F.
Okay, so this has binary counter. Okay, so now let's do binary counter. Yeah, you see, so it's showing counting binary numbers, and you can see that number at the left is less frequently blinking than number on the right. Next, shift register.
Oh.
Okay, let me get water. Okay, so did you install?
So it installed it. I
All
was able,
right.
so something moved. I was able to say synthesize for FPGA.
Did you choose board? Ah, yeah, you did. Oh, you don't need to resynthesis. You can just do. No, this file too late to stop it because it already erased everything. Okay, so now let's see what is here.
And it says it was successful. I see lots of green, but
But it doesn't
microprocessor
work.
don't do anything.
Okay, first of all, let's make sure that you choose correct board.
Yep.
So what board? What
16,
board
right?
is this?
It's either 16
D1. Yeah.
or 23.
No, this is clearly D1.
How
This
do you
is
know
not
D1?
16.
What is D1?
It says D1 here on the box.
Yeah, it
Oh,
says it says D1 here on the box. So okay, the board is D1. So this board unfortunately doesn't work. Okay, let's
What's
see.
What's 23? D1?
D1 is a different board.
Okay.
It's a different board. Okay, so now let's see why it doesn't work. So first of all, it's very weird that
Can you run and proc? Maybe it should be in run. No, this one.
it's possible. Okay, let's try this. Let's try it again, but only 4.
So if you try to do synthesize for FPGA while it's in run,
Ah, yeah. So you should do run, not a proc.
in proc it was not doing synthesize. It was failing synthesize.
No way. This shouldn't affect synthesis at all.
Okay.
No, but wait. Now like it's too late to like interrupt
What
it
happens
because of it.
if it interrupted for some reason? Will it break?
No, like everything is alright. You see, so this works. Just fine.
Okay.
So now let's go. Yeah, see, so if you press here, both LEDs are on. If you press here, both LEDs, but if you press both of them, they're off.
Excellent.
Go to next exercise. Okay, so how you're doing? Did you turn it on?
Well, it won't matter because it doesn't fire.
Okay, let's see. Let's put bash synthesis. It's seriously. Okay.
Switch.
No, that's fine. That's fine. Just now the question is that whether up to date, git fetch new graphics. Let's do git fetch new. Maybe it has some stale version of new graphics. What? Just a second. Is up to date. Okay. So now let's see what is the error. Because this is a new implementation, error is possible. Object not found. Oh. Oh, yeah, D0CV, which is correct. Okay, D0CV. Now, first of all, let me see. Okay, first of all, let me see if I have correct. So you have it in search, right? Yeah, okay. First of all, let me see if it has the most up-to-date thing. Board D0CV. Because if you have obsolete version, certainly. Okay. Is it something which I modified yesterday? Yeah, it looks like it's correct. Okay. Yes, this looks correct. Okay, this looks correct. Fine. So now let's see what kind of errors we are getting. Yeah, this is normal. I didn't expect this to work from the first try. Oh, wait. Let's do bash this thing. This it does it here. Okay, so now you see error with can't open project. Ah, yeah, it cannot open project because there is an error here. So let's see what kind of error. Error reading Quartus settings file. What? Okay, let's do clean. Bash clean. Okay, the git diff. Maybe there is some. A second. Something is differently wrong. Oh, wait. Why it's using Altera 13.0 SP1?
That normal?
No, it looks like it's trying to use all the tool chain.
Old one?
Yes, it's supposed to use new tool chain, but it uses old tool chain. So why is it using old tool chain? Maybe this is bug in a script. So let's see. First of all, let me see what do you have installed. Okay, so yeah, there is an InterFPGA Lite. There is InterFPGA Lite installed. So why it's trying to use all the tool chain, and there is also Altera.
I think it's configured.
Yeah, so basically it has two tool chains. Maybe it get confused. It get confused with the tool chain. This is a good thing to know. So now, I know what's this. Oh, I know. I made a bug in script. So now, what we can do is, if you go to script, if you go to this setup script. Or did you connect power? Maybe it ran out of power. Yeah, it's not connected to the power. That's
No, it's plenty of power, yeah, on left.
okay. So now, okay, I accidentally pressed this one. I need to press something else. So I need to press funk. Yeah. So now let's find here D0. I think I know. I think I know what happened. So you need to find D0. So now it does use old version. Yeah, but it's supposed to go to D0CV. And D0CV. Yeah, it's not. It doesn't use old version. Very interesting. Okay, FPGA toolchain Quartus used old version. Yeah. So now we need to figure out whether It's trying to use old version or not. This is strange.
How about we try running one of the other scripts in the same class?
Yeah, we can, but I seriously suspect. Okay, use old version. Okay, let's see setup. Let's see what it's trying to do if it's doing setup. I mean, what we can do, this is actually good thing in testing. What we can do is we can simply rename Altera into like Altera 1, you know.
What's the point?
It will not recognize it by name, so it will use
Okay, so
new
use
version.
another script instead.
No, we're not using script. Okay, our script is trying to find version of Altera, and because there are two of them, it gets confused. So now, first of all, we can look to the logic of a script. So logic of a script is here, and like apparently this is a bug that if it has two installed, for some reason it uses old one instead of new.
Okay.
Oh, first of all, what does it say about found quartus? So info when quartus is found. Okay. So if it uses old, so if old version of quartus is equal 1. Oh, okay. Oh, wait.
Two of them.
Okay, one thing.
Is it supposed to use?
Let's actually do first clean. First of all, let's close everything. Let's close everything except for one window.
Okay.
Oops, sorry.
Okay, sorry, it's like that.
Okay, so first of all,
Supposed to use Altera or Intel? The PGA.
So for this particular board, it's supposed to first try to use Intel.
Okay, and if the Intel thing works, then it will use that only.
Yeah, then this will use the thing only. So it's not supposed to use Altera.
Okay.
So this means that there is some problem with the script. So, but first, in order to eliminate, we just sorry. In order to eliminate, we just first of all we clean all like unnecessary files. So we do git clean and dot dash d dash x dash dash n. So does it have anything to clean? Only this preview. Okay. So now this is first. Second we do git pull. Okay, so we have everything here. So now we are going here. So first of all, if you do git clean, okay. So let's try to do synthesize, and then we do D0CV, which is 11. Stop. Yeah. Okay, so now.
Did it work?
No. So now can't open project, loves basics, run FPGA project. So cannot run, okay,
So
FPGA project.
isn't it supposed to run the other script if it doesn't work? Or the other
Just a second. First of all, it's running old thing. It's running Quartus 2 instead of. Okay, first of all, did it create project? So it's supposed to create project inside run. So it does here QPF and Q.
oh
it created here QPF and QSF. So it's trying to run certain zeros. So now let's figure out why it's trying to do certain zero.
Okay.
So in order to figure this out, we are going to projects, we are going to scripts. So now we need to debug script. So now we are going to the script. Oh, so in order to debug script, we can use -x, or we can simply or we can simply go here. You can simply go here and put something like echo old, and or you can go here and put here echo new.
Okay.
Okay. So now you see what it prints, and now we are going at the end and put here echo use old version of Quartus. Okay. So dollar use old version of Quartus. Okay. So now we are trying to run it again. Opa. Okay, so now, did it print anything like that? Yes, it put new, it put 0. So it put new and found Quartus using Quartus root dir. So apparently when it was installed second. It was installed and it used environment variable Quartus root dir,
Okay.
which we need to reset. So now echo Quartus root dir. So it is trying to use Quartus root dir.
Okay.
So, and because it's trying to use Quartus root dir, what we need to do, or maybe actually I put Quartus root dir. I don't remember this. So we need to go to system environment and we need to unset it. So where is environment? Yeah, edit the system environment variables. Yeah, maybe I was using this for environment variables. So user profile system properties. Yeah, environment variables. So we have here, you see here Quartus root dir. This is Quartus root dir for 23, which is correct. And here we also have, so here the system variable is Quartus root dir, and this is user variable. And this is user variable which doesn't have this QC. Okay, so this says Quartus root dir, this environment variable.
Yeah.
Okay. And I'm not sure whether I put it or somebody else, but whatever was here, we need to unset it or rename it. So now we rename it. Okay. And we press OK. So apparently it's trying to use old version. But this is actually weird because I thought that even with old versions, this still should work. So now let's clean it up and let's synthesize it again. What? Maybe we should exit here. So Quartus root dir found. Maybe we should reboot computer.
Okay.
So let's reboot. But this is interesting. So it uses Quartus root dir. So let's reboot computer and let's see what happened with the Quartus root dir. So your you actually got into a bug in setup. Oh, sorry. Which is, oh, which is actually very useful because this is actually what we are doing. We are trying to find some buggy situations. But this thing is supposed to work even with older version. Ah, no, with older version does not support Cyclone 5. Yeah, older version does not support Cyclone 5. Okay, let's see. So now I can try it again. So you're going to projects, going to labs here, so you clean, and we do synthesize. No, it still uses older one. So where did it get this environment variable? It got Quartus root dir.
Same one.
Let's go to environment variables again. So environment variables. Edit environment, yeah, edit for your account. Maybe it's for your account. Okay, so this has system variable for PCQCs and so it Quartus root dir rename.
Have you, it's, okay, I got it.
This is weird.
Maybe path?
Ah, yeah, you're right. Maybe it was in a pass.
Yeah, maybe.
So let's say it pass. Yeah, but even in the past it was saying that it's found using root dir. Okay, this is the edit pass.
No, it's not there.
No, it's not here. So what about pass here? Why did you get root dir? That's insane. What? Okay. Yeah, edit system environment. Ah, okay, it's here. Performance user, okay, environment variables here. QCS root dir. It's not ours. Pass next. Okay, so what we do is we do bash. Okay, we do env. So now we can do env grep root. Result there.
It's there again.
Ah, here.
It's caching it.
Hmm. Where did it get?
Saving it locally on maybe bash saves it locally and then.
Ah, yeah,
Because once you
maybe
clean
it's saved in a bash RC somewhere.
So maybe clear somehow.
Hmm. I never saw it. So. Damn. Now I'm puzzled. Okay, so okay, so first of all, where is the bash? Ah, it's supposed to be Windows. Okay, so first of all, which bash? It just show. Just show. Okay, so this is supposed to be in a Git. So where is the Git installed? It should be in Windows applications. Yeah, program files. So it's not here, Git. So does it have RC? First of all, let's see what happens if you modify script and script. So if you just remove, this is interesting thing. I didn't experience it before. So first of all, let's modify scripts and then we will figure it out.
Okay.
Because we just like found it, so I will figure it out by myself. But now what we need to do is that now we need to prevent it from searching for this root dir. So now it's attempting to find using root dir. Set of quarters. Yeah, so this saying that if quartus root dir is set up, so what we do here is that we say that if nothing, then so this is the way how to comment it out. Phi. Okay, so now it will not try to search for quartus root dir. Okay. So now we clean this thing. Oh. Now it raises interesting question. The question is that whether old version supports cyclone for yeah. So now it's doing something. But where did it get quartus root dir? This is a mystery. Okay, so now you see testing is very useful. So now quartus 13.0 support quartus. Okay, so now latest version for device support. So Cyclone series, Cyclone 5. So latest release for Linux. Okay, so Quartus version Quartus 13.3. Yeah, so this is Quartus 13.3. So let's see what it supports. So Quartus 13.3. Cyclone 2. Oh, let me see here. Oh, this is weird. I never see it before. So somehow it memorized. Somehow it memorizes that variable. So if you go to Altera, yes, 13.0. Quartus. Yes, so readme. So if you go to readme, let's see what it supports. License. Ah, yeah, libraries. Common drivers. Ah, wait. This is what we do. Quartus download. So Quartus Prime download. light edition. Okay, so now we are looking for web Quartus 2 web subscription, and we are going to 13.0, and let's see what it supports. Individual files. Aha. So it supports Cyclone. It does support Cyclone 5, including call variations. So now the question why it didn't work. Because actually it's supposed to support Cyclone 5. And this is Cyclone 5. But maybe it got confused because it was getting some files from old version, some files from. Okay, so now does it work now or not? Okay, let's see.
There's also another.
Yeah, but this one go hard. Oh, okay. Here you need to put it to run. You have to put it to run rather than to proc. So now if you configure it.
There is no link there. You can check. Or you can try to get.
No, it says that the file is not a. Oh.
I don't have it.
What? Did it synthesize it?
Where can you ran the third script?
Did I accidentally clean everything?
I think it will work this time.
Okay.
Wait.
Well, it did take a minute.
For each four, what are you trying to do? Then, if you need, direct tool chain, installed in the image.
This is interesting.
Which tool chain you need? The direct to this, because that it has nothing is going and going for the next one. Or for the before.
Mhm.
For this one, it is what it is. Like this one, take my purpose, 13.0. But when you run that, if you run.
Does your son want to be an engineer like you?
Huh?
Does your son want to be an engineer?
No, he wants to be a doctor actually.
Oh,
So
okay.
he was studying biochemistry and wants to be a doctor. Yeah.
So he doesn't like your.
He wants to go to medical school. Yeah. I was trying to make him like play with the PG and other stuff, but yeah, so no, okay. So you can now try like other tests. Yeah. Yes, you can actually chat with him, but he is very like impolite. So he is like
He's direct.
yeah.
Direct.
He's like in polite teenager stage. So it's like okay.
He's a rebel.
Yeah. Yeah, but since you're from UCLA, since he's very focused on study, he may be actually interested to ask something about about school.
Oh, okay.
Yeah. Okay. So were you able to figure something out here? Okay. This excellent. Yeah, let me actually look to your pull request. Okay, so what we are doing here. So what example?
Write all samples which you do. That's very slow machine.
Yeah.
So I stopped on 07, 107.
Yeah, this one. So you want to try GUI. Yeah. In GUI, you need to go to compile it again because apparently GUI has a bug and it doesn't, if you synthesize it partially. Oh, wait. How come? Did you try to open something in GUI?
No. I just run with 05 script, which opened with GUI. Maybe it was not open correctly. It's very
No, it's not open correctly.
okay.
But did you synthesize first? So you need to synthesize first and then run GUI.
Mhm.
Okay, so you synthesize first. Okay, and then you run GUI. Let's see.
Oh, okay.
Yeah, because without synthesis, it doesn't know where the project is located.
Mhm.
But unfortunately, after this, you have to resynthesize it again because it gets confused easily. Yeah.
Yuri, may I take your opportunity to take this spare Altera port, or what do you have?
Yes, I can actually give you. I have spare Altera boards. First of all, I have two Altera boards A1, and second, I have two. D0. I think I gave one D0 to somebody. Yes, I gave one D0 to somebody, but I have a spare this one. So I have.
Okay.
You can actually test it now whether it works. Yeah, you should test it now. Yeah,
Okay.
but this requires all the version of toolchain if you have it here. Let's see it.
Yeah,
No, but I think that you should have it here. So what you can try it right now. Yeah, so you see, you need to like compile, but let's see whether you have a different version of toolchain. Yeah, you can try it right now. Just
disconnect.
yeah, you can disconnect. It doesn't matter. I think this uses different power supply.
Oh.
Yeah, you need to use for all Altera boards. They have individual power supply with different voltage, so you need to use the different power supply. Yeah, it's kind of
Not toasted.
yeah. Okay, now this one you need to. I think you may need to install.
Sure.
Okay, let's see. Yeah, for this one you need to install different toolchain. But the good news is that there is a toolchain in install directory here. So you need to do same thing. So what like Timothy did, you need to install old Altera toolchain. So this old is here.
Mhm.
Yeah, but you install using Linux. Yeah, so you just get it from here, and you use is a Quartus Web 13.0, Quartus Web 13.1. So like anything you like, or you can install both of them.
Which one is better? Just tell me.
I want you to test with the both. So if you can install both of them, I can even loan you this computer if you want. So, but I want you to test for both. So now let's see. I want to test all examples for all boards. Yeah, okay, so here we have Intel FPGA Lite, and here we have Altera. Yeah, so what I want you to do, I want you to install old Altera. Okay, so what you do is you create a temporary. Second, let me do MC.
Are we installing from scratch or what? Or maybe we can do on bigger machine?
No, this is fine. This is fine. Let's install it here. This computer has a large hard drive, so you can install anything here. And actually, I want to test what happened with the two two different installations, so maybe even three. Okay, so now, why doesn't create a new directory? I think we have too many things open. Yeah. Wait, mouse. Okay, I want to close this one.
Hey, what's up?
Let me end this process. It's too slow. Yeah, let's actually close everything.
Yeah.
Yeah, so this computer is too weak for GUI, but still I want to
I can,
test.
we
No,
can
no,
try on Google.
this fine. We start the computer, yes, because I want. Yeah, but you can install it there if you want. Yeah.
But
Let me give you SSD. Yeah, let me give you SSD to install. So let's install it on that computer. So from this SSD you can actually get everything. You can get Pogovian as well. So this SSD has the old Altera version. You can here. Okay, so now just copy all.
copy what? Copy.
Okay.
Take a seat if you please.
Yes, this fine. So you go to this EDA tools downloader, you go to Altera, and you just get files from here, like any file you want. You get like Linux. So since like Kevin is trying 13.0, let's you try 13.1. Okay, so just like copy the 13.1 somewhere, like untar it and start installer.
Okay.
So it's supposed to install and just install it in default location. Okay, so how are you doing?
So
You're looking to hex counter, yeah, okay.
the first 8, 9 work just fine. So things seems to work.
Okay, snare FSM. Okay. Yeah, so this is finest. Okay, so next one requires bringing displays, so we can bring some displays. Yeah, I think I will stop online meeting because we are just doing now test. And they will kick us out anyway. Let's see. This one is mine. This one is mine. Okay, so yes, and I can show you what you have to do. I have an instruction for it. So you need to 1 second. I know what to do. I have an instruction in a Hubber article. Hubber. Let's see. This one here. Okay, first of all, so libraries, Quartus. libraries Quartus 13.1. So first of all, you can Google libraries Quartus 13.1. So installing Quartus can't find shared library. So make sure not to hard copy any libraries. You need to do sudo apt-get. So make sure not to not to try to copy library. There should be sudo apt-get. I have it somewhere. Just a second. I have it somewhere. Mm. Mm. R13. О, yeah. Quartus 13. I will find the list of the list of things. Just a second, yeah.
Yeah.
Quartus.
Yeah.
Yeah, it's a kind of interesting question. Copper. Oh, you know what?
What?
Quartus, Quartus, Quartus. Oh, yeah, here missing library in Quartus 2. Yeah, so oh. Wait, it should actually complain about missing libraries. It should not. It should complain. So from this you need to do sudo apt-get. Yeah. Yeah. 1 second. We'll figure it out. Okay. Let me try.
Yeah, sure. I also found this one, but it's
Yeah. This is fine. So
tried
you
this.
must install 32. Yes, 32
it
of the
cannot
current
resolve,
stores.
cannot
Yeah.
find.
So no, this should be done in different way. 1 second. The problem is I went through it many times.
This one.
No, no, no,
You
no,
must
no,
have
no,
it.
no, 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 no. Yeah, libraries for quarters. Yeah. One second. I didn't just need to recall what
That's fine,
exactly I
that's fine.
did. Yeah.
Take it down. Maybe you can later like just ping me some solution. I can follow up at home.
No, no. I did it many times. Oh, you know what? Let's do here history. No, let's do history on this computer because I installed some more. TV history. Yeah, bash history. No. Get update. Oh, here. Extra install. So there is a cat extra install libns1 lib. Yeah, here. Okay. You need to install the following. No, it's a different one. Sorry. libnsl2. Yeah. Up. Okay. So try to do this. Sudo libnsl2 libnsl1. There are a lot of them. No. This is something else. This is for 3D graphics.
No, it looks similar. Lead KX, XX, this is what actually.
Okay, try. Try to do.
Yeah, I tried. It enable blockade package lead stack, for example. Oh, you have, okay, gotcha. You have it more comprehensive. Okay, yeah. Wait.
First of all, sudo apt get update.
Update, upgrade, I did.
Yeah, okay.
So it's the Lebanese 12
Yeah, libns12,
and 12. What else?
libns1 so1.
So Lebanese 1 dot so 1.
Mhm.
A D PNG 12.
You don't need to install them at once. Just install one after one.
Okay. I guess it's easier to
Yeah.
combine. Lead free guy. You should put it on some instruction.
Yes, I have it in some instruction. I just cannot find the instruction. I wrote this instruction. I have this instruction. I mean, like just like end of the day, my just head is like foggy. My brain is foggy. So
So the one.
let's do this one by one. So that if you mistype something,
Okay, I take it. Okay. So, old.
okay. So interesting.
Okay. Lead.
Zero.
So
Lib.
But it did install at least libnest well. Yeah, it installed 4 of them. So unable to locate this one. Libuso, did I mistype?
Yeah, you missed that.
Okay, you can delete.
No space.
Oh, sorry. Oh, okay. libns1.
Ah, wait, this is different Linux distribution.
Debian.
Yeah, this is the for Debian you need something else.
I can Google it at home.
Yes, I am. I was able to run it here. Just
Maybe history. Check. Do I need? Maybe I can check history.
but if it doesn't work right now, it will not work with history. Okay, first of all, let me try to run.
Mhm.
Wait, no. 32-bit compatibility libraries. Quarters to installer.
Oh, interesting.
Let's just
oh,
Google this.
Yeah. Okay. Yeah, I'll tap or something.
Alt tab, okay.
Uh-huh. Like here. Yeah. Mhm.
Okay.
Sudo bar. No, this is a question. We need to call for answer.
Okay, go here. Oh, this one.
What is one?
This one.
libx. This one?
Sudo.
Okay.
This one. This
Okay.
is the list.
Okay, I can try.
One second, second. Because maybe this is for model sim.
Model C.
Okay, so let's try this one.
Yeah. That's it.
Okay, so now sudo apt-get install.
Yes.
Okay, we are practically there.
Awesome. Where was the second command mentioned on the page?
Yeah.
Maybe let's install it just in case. Yeah, release. Yeah, everything.
So,
Let's install it.
yeah, if you don't need some.
That's it. Oh, let's do it.
Okay. Now, sudo apt-get install this one. Huh?
Yeah, maybe a second command not. Let's try to run setup. Maybe it works. Yeah, no. No, interesting.
Yeah.
Do we need to reboot or what? Restart session?
No. At some moment I solved this problem. I just don't remember how. Oh. Okay, so this was his question. It
Okay,
was his
let's see
answer.
answer.
So okay.
Two answers. So for item. Oh, we want to.
This one.
Yeah, we're trying to install.
Such things shouldn't be in a hurry. This is like old version of Quartus, which is which requires 32-bit libraries.
Also, this is not the latest version. 13.1. Oh, okay. I guess it has 2 times sudo apt-get install, sudo apt-get
Ah.
install.
Let me find it in my
Sure.
in my email because I solved this problem before.
Okay. I can Google it also. Try to follow up.
No, I definitely have it in
Somewhere.
Okay, I will find it now.
Yeah.
Now, like I just want to find it
Yeah.
because I have this. Okay.
So what is run?
Oh,
What
there.
so
Oh.
because it works. Yeah.
It requires 32-bit library. I know this for sure because I solved this problem in the past. But I just need, and I published how to solve it. Just I need to find. Okay, let's see. You just need to find what libraries libraries are missing. Find it in my email. Oh, here. Ah, no, this is RPM package.
Yeah.
This is different. It's different, yeah. Oh, this one. Try this one. Sudo apt get installed libpng 12.0. This one.
Yeah, right.
PNG.
Yeah, libpng 12.0. libpng 12-0.
again? Like, maybe
The problem is that I documented and published article how to work. Just right now, I don't remember where.
what's the sources? Where? Cover?
Haber, Live Journal, Facebook, I don't remember, but somewhere I put this
Try
command
to do
line.
it. Yuri Pancho, cover.
This is what I'm trying to do. I don't remember. This was long time ago. I just remember that I was able to overcome it somehow. Okay, anyway, I think you should stop this one. Ah, yeah, okay.